have a quiz. Everything's up on Schoology if you guys have checked to see when your quizzes are and stuff, right? Okay, so we're going to do exponential functions, our essential learning. This is a green one. If you don't have it, I got an extra one here. Probably have some more. Exponential functions, domain, their range, their graphs, applications, and laws of exponents. Oh, something that usually takes you about a full unit. We're going to do in about 10 minutes. So you have time for your homework quiz. If you've done your homework, that shouldn't be a problem. Okay. I don't know what I hit. Hopefully nothing important. Okay. What do these look like? What's true about a to the x? If I have y equals 2 to the x, 3 to the x, e to the x, when x is 0, what's the y value? 1. So they all go through 1. And the only thing that's going to change is to be the steepness. I don't really care about that. I care that you know that this is y equals a to the x. Okay? I need to slide it there well. What about the second one, minus a to the x? Uh-oh. Hopefully it's there we go. So I'm going to take this out, and minus flips it over what? The x-axis. So we are going to flip. Any particular color you would like? Green better. Green. Okay. Should, yeah, actually move to the right a little bit. Okay, are we okay with that? You are expected to know those. You need to know the next one. In particular, it's going to be e to the minus x. But it's a to the minus x. So I'm going to clone that. And we're going to flip this over the y-axis. Now what color? It's already black. No, it's not. It's green. Red. Well, you know what? I'm also going to bring up my Inspire calculator. And those are the three. You could, but this is the most important one. Y equals a to the minus x. The green one, well, they're all important. It's equal to minus a to the x. So actually, I have my calculator up. So I'm going to go to a new document. I'm going to graph it. But, oh, no. I never save. You might save if you want. But anyway, I'm going to add a graph. And we're going to graph e to the x. Because e to the x is the one you're going to see. Plus, I can't do my magic with Inspire on 2 to the x. It only works on e to the x. You may not type in e. You can type in the sign and a whole bunch of other stuff. But e, if you want the number e, you have to actually use this button on this calculator. So we're going to do e to the x. And we're going to graph that. Then we're going to do minus e to the x. Now I could go minus, if you're interested, f1 of x. It should get bold, because this is already defined. It's like global variables. If you are into programming, you'll know something about that. There's that one. And then, actually that's pretty nice reflection, isn't it? We want to do e to the minus x. This one I'm not going to be able to do easily. So, actually I could. How do you think I could use function notation? You think I can do it? Could I do f1 of minus x? Should we try it? I haven't tried it. And I have to have the minus sign. Minus x. Oh no, because I know what it looks like. There it is. There, whoever black. I thought it was much more black. There it is. Can you ever get e to the x to be negative? I know what I'm going to do. I'm going to grab this. Well, look at that. They're all tied together. So you can see the reflection. That is cool. I've never done that. And I'm going to try and make them all flip over the x-axis. And I'm not able to do that. E to the x is always positive. So let me do it on another screen. I can't. Because I tie them together, so I called it F1. Isn't that cool? And what's this? What's the base? not e, it's 1. No, probably was someplace. Get an exponential function. So I can shift it like that, or I can grab it. I might not be able to grab it anymore now. Sometimes it gets messed up. I'm going to grab a different one. No. You have to see the little other thing. So I could just add a page. It'll be clear if I do. And let's just add a graph. And we can do e to the x. New color. Next color is orange, I think. Okay, I'm just going to take this one and try and make it negative. So now do you believe that e to the x, no matter what I do, is never negative? You need to know that when you get into the calculus part, max and min, things like that. Okay? Let me write that down. A to the x is never negative. I mean, if you make a negative in front of it, that's fine. But not necessarily. Okay? Graph 2 to the x and 3 to the x, and then graph the tangent line. This is like homework. And what is the slope? Suppose you want me to use the smart view. What is the slope? Graph the tangent line. Let's try our calculator. I'm game. Are you game? Okay, I wanted to do graphing of, we took mine, it's 2 to the x, right? What was the other one? And then 3 to the x. So I'm going to tab it, and I'm going to do 3 to the x. I'm not sure, honestly, I'm not sure how to do the tangent lines on this. We're going to find out. They're pretty close. Take the rows in the back. They're pretty close. And I want the tangent lines, and the tangent line is 1. So I'm going to go to menu, and I am going to, I'll escape. In the graph mode. Geometry. 8. I want a point and line. And I want a tangent. 7. I have this. And I'll put it on this one. You can't do this with your smart view. Lizzie, where are you going? What'd you say? Matt, what'd you say? I don't know if I did, but not everybody has that. Doing it on the other one. Now, I think I have to press enter again. There it goes. I'm going to escape. I can measure the slope. I am going to grab this. Easy for me to grab it this way. And then I can drag it around here. So I would like to measure the slope. That's possible. You go to menu. You go to geometry, measurement, slope, and I want to do the slope of this line. There it is, 8.39. Okay, so I'm going to escape, so I don't want to see it doing anything. And there's the slope. I didn't label it. I put. I thought I did. Oh. I want to grab it. Oh, I'm still in this. I thought I hit escape. I didn't. Okay, now I'm going to grab my point. And you see the slope changing? I'm going to move that text over there so you can see it. See the slope changing? I want the slope equal to 1. No, you got to do it this way. And then you can do, I want to get the name of that point. I'll do it. Probably trace. Yes. Yes. That's all it's asking to do. Escape. Escape always helps. Yes. You have to do it with the calculator. So if you do a smart view, you didn't want to do that because it takes more time. I know, but it's kind of cool. But you have the same options. Let's look at it. Now, you don't have the dynamic ability, you guys. Okay, you guys? You don't have the dynamic ability like I do. So it's trial and error, unless you want to calculate the derivative. We can. Okay, I don't want to see this. So I'm going to clear that out, and let's just do 2 to the x. And we're going to zoom at 4. I might want my y values to be taller, so I don't want zoom, I want windows. Okay, you guys, in the front, graph. And guess what? We want to draw a tangent line. Where do you think the slope is about 1? Well, looks like it might be at 1, doesn't it? Maybe it's over here. Okay, so you go under program, not program, excuse me. You go under draw, second draw, which is above program, and you can do a tangent line there. And we're going to do it at 1. See if that does the trick. I thought I knew how to do this. Graph. I should just be able to do this. Tangent. Okay. Where'd you guys say what you think it might be about 1? 2.29? 2. You want just 2. Well, that's 1.2. That looks steeper than 1 to me, but we'll find out. Press enter. Draws the tangent line and gives you the slope. Slope is, what should give you the slope? Huh. Didn't give us the slope there. Yeah, that's right. So, second quit, graph, and I don't, let's see, I don't have my labels on. That's my problem. So second format, labels are, I want them on. Okay, you guys have this ability to turn the labels on. I don't know why they're not on. I kind of like them on. Graph. Not those labels. Expressions on. That's what I want. Expressions are on. I don't know. Oh, I know how to do it. Graph. Knowing 2 calculators is not fun. We're going to trace. See if we're on the line. It says it's 2 to the x, so I go down here. I should be able to. Oh, you know what? I can't trace on it. So I would have to do it again. But I don't think your line was in the right place. Second draw, tangent line is 5. Let's do it at. Do you think that's 1? Well, let's try it again. Enter, because I erased it. What happened? There. Y equals, it's 2.77. It's too big. This is not a square window. So if I zoom square, let's see what happens. Did you ever zoom square? If you want to see a circle, you got to look like a circle, you have to zoom square. I did. Zoom, I might be off. Square is 5. So now if I do my second draw, we already know it's 2.77. So let's do it at 1.5. Still looks too steep, doesn't it? It's just trial and error. It's not a big deal. It's not worth spending a lot of time on. Okay, for what value of x of a to the x gives a slope of 1 for a tangent line? You want to remember the derivative of 2 to the x? Do you remember what it is? Do you remember the derivative of 2 to the x? Do you remember the derivative of a to the x? Times of a. So if you want to do it algebraically, it's 2, well, it's not. You have to still do it practically. That's not true. That has to equal 1. So you could solve for that, but that's a little bit beyond what's being asked here. You won't know what the derivative of that is. I'm just reminding you because you do know. This is not a Calc 2 book. This is a Calc 1 book. In other words, they haven't done it. Not to worry. This is a little more important, but let me make it so you can see these. Do you remember the laws of exponents? Okay, do you remember how to simplify that? What do we do with the first one? Add the exponents. If you forget, Then write down x squared times x cubed, and you write down what it means. Oops, 2 minutes. Went to the answer. And so you count them all up. An exponent is how many times it was multiplied. That's what it means. Oh, sorry, should have been x. Okay, what about this one? This is x to the what? A minus b. Or you could have 1 over x to the what? B minus a. What do you do with these exponents? Okay. Do exponents distribute over addition? If I have x plus 2 squared, is that equal to x squared plus 2 squared? No. So exponents do not distribute in all situations. Limits distribute. Derivatives do not always distribute. Okay. Do you remember how to do half-life? We will. That's a promise. We are going to do this. We're going to do derivatives. And then we'll do Chapter 3, applications of derivatives. And then we will end up in, no, actually Chapter 2 is limits. Chapter 3 is derivatives. And then we'll jump to Chapter 8. And I'll have to put some stuff with integrals in there. Okay, a radioactive substance has a half-life of 700 years. Do you remember PERT? The principal equals the original amount, e to the RT. So, half-life, I got to figure out what R is. So the radioactive substance is going to have half of it left. I don't know how much we start with, so I don't really care. And it's e to the R, and what's the time? How many years to do half-life? 700. And even I'm rusty with this. Okay, these guys cancel. How do you solve that equation? You could do it graphically, or you could do it algebraically. E to the 700R. Do you remember how to do that? Take the log. I think this may be calculator based because the logs are in the next section. So it's the log of 1/2, but we remember it, right? Do you remember what to do with this exponent? Put it out in front. Excellent. So R is equal to log of 1/2 divided by 700. Some number. I don't know what it is, but it didn't answer my questions. If there were 10 grams initially, how much would be left after 300 years? So I'm going to go back to my formula. I've got a lot of good stuff there now. P, and I'm sorry it's low on the board, but I can't see what I have up here. I'll try to slide it a little bit. Is equal to the initial amount, which is 10 grams. E to the R, which I have no idea what that is. Is that a positive or negative number? It's decaying, right? Negative. We'll talk more. When we do logs tomorrow, I'll talk about why that's negative. And the question is, after 300 years. And you know what, as far as I'm concerned, that's done. If you were in the AP exam and they asked you that, I would leave it. I would not go and get my calculator out if it's a calculator question. Full credit. The initial amount is 10. R, we just figured out, was this. And the T is how much will be left after 300 years. It's interesting because you still have some. That's the problem with, where is it, one of the power plants where they're using nuclear energy here. And the Indians are not happy because they said they would move the nuclear waste. And they have not done it. If you watch the news. Yeah, it's on your handout. We won't be here in 300 years, but this will be. So what are we going to do? This is going to be a problem facing your generation. What are we going to do with nuclear waste? They'll all be gone. In 300 years, I'll be gone. Okay, how do we do this one? This is a graphing calculator one. Where's going to be the problem on this one? I got my smart view up. Might as well use it. Well, we want to be done here. Okay, Grant. Y equals, I'm going to clear. Okay, e to the x was e. It's almost in the same place. What is is that? 10 to the what? Okay, girls, we'll get done faster. 10 to the what? No, it's a million. It's 6. Okay, here's the problem. I see nothing. When you look at your window, remember e to the x is positive. Well, I see a little graph. I see my e to the x function, but I don't see the answer to that. And I don't know what my x's are, but you want to try a zoom fit? Zoom fit does not always work. This could be the case when it doesn't. But what's nice about, and I know you don't have the inspires, but what's nice about the inspires, I can just grab the axes and move until I see the other function. Okay, that's better. It's not great. And then you guys remember how to find the intersection point? That is great. Yeah, it's a calculator problem. Where is it? There it is. And so we go second, calculate, and we're looking for an intersection point. Now, there could be more than one intersection point, so that's why they ask you to guess. And there it is, 13.81 years, or whatever it is. Okay, I think that's it. Oh, wait, I got one more maybe. Yeah, and I did a zoom fit, but we can print it up. Now, if you don't have the right, look how big that is. If you don't have the right domain, that's a problem. Good, one slide. So it's going to be the window is going to cause you the problem. Oh, okay. We're going to leave that. You can try that graph. I can leave that up for you to work on after you're done with your homework quiz if you want. You should be able to graph that without a graphing calculator, and I think that's the last slide. Yes, that's a blank page. Okay, now, here's the thing when we do quizzes. We have to move our desks because there's a lot of you in here. So they're going to have to all be separated before you leave. It has to all come back to where it is right now. Yes. There's no calculator. No, we don't